Hello and welcome to Tribe Topper. In this video session, you are going to learn about traveling waves. So what do we mean by traveling waves? See, a wave is just a pulse, or you can say a disturbance. Like you disturb a rope, just give it a jerk, it will travel all the way from left to right. So what will be a traveling wave? We see that when the positions of a maximum and minimum amplitudes that travels throughout the medium, that wave is called a traveling wave. So if you see here, you gave a pulse, you can say just a jerk to a wave, to a rope, how it is going to travel? This will travel from here, then go further, and it reaches here. In the next moment, it's here. So your amplitude is shifting all the time. So it shifts from here to this position. So that means the position of your maximum and minimum amplitudes keeps changing. It is traveling through the medium. That represents a traveling wave. The traveling waves can be classified as transverse and longitudinal waves. So the first one is a transverse wave. Just as we talked about that you give a jerk to a rope which is tied at one end to a, say a string is tied on one end to a rigid support, and here you gave it a jerk. You know that how the wave is going to travel. It will travel all the way from left to right. But what you see is that the wave is going up and down, up and down. So the particles of the medium are vibrating down, up, right? So at each moment, each instant, they are traveling or they are vibrating perpendicular to the direction of propagation of the wave. Propagation means the direction in which the wave is traveling. So what is a transverse wave? A wave is transverse when the particles of the medium vibrate at right angles to the direction of propagation of a wave. And a transverse wave travels or moves in the form of crests and troughs. So we have a crest here and a trough here. Crest refers to the highest point, the point of maximum positive amplitude. That's a crest, that's the top peak. And the bottom peak or you can say the point which refers to a maximum negative amplitude, that's called a trough. So crest and trough, this is how a transverse wave travels. Now what is a longitudinal wave? So longitudinal wave, let's say, as you can see in this example, suppose you stretch your spring and release it. It sets up into an oscillation. You can see this is how the spring oscillates. Somewhere it contracts, then it moves on further, then it compresses again, then moves on further. So your particles are also vibrating left to right, left to right, left to right, and the wave is also traveling from left to right. So the wave has traveled from left to right, but at the same time the particles were vibrating in the same direction. So in a longitudinal wave, the particles of the medium vibrate parallel to the direction in which the wave travels. So they both move in the same direction. But if we take the graphical representation, that will look like a same wave. But what is the difference here? The top peaks would be known as compressions and the bottom peaks would be known as the rarefactions. So what is a compression basically? That is this region where you have the the particles are very close together. So we can say a compression is a region in a longitudinal wave where the particles are closest together, and rarefaction is just the opposite. It's a region inside in a longitudinal wave where the particles are furthest apart. So this is a sound wave diagram. So this speaker is producing a sound. It pushes the particles, it produces some vibrations, right? So the particles are pushed to the right, so they all compress in this region. Then they again, because they are vibrating left to right, so some go here, some go here, and then again this side compresses here, this side compresses here. So this region is again where the particles get compressed, but the ones which were vibrating to the left and right, they got scattered away from each other. So that region is called rarefaction. So these points where you can see they are closer together, they refer to compressions, and the points where you see the particles are further apart, this one, they refer to the rarefactions. So rarefactions are where the particles are vibrating in the opposite directions, right? Like this, and they move away from each other. Compressions are the region where the particles are vibrating towards each other. So if you plot it graphically, so you see the top peaks are referring to these compressions and the bottom peaks are corresponding to the rarefactions. So this is how a sound wave or any longitudinal wave travels in the form of compressions and rarefactions. So that's all in this video session. In the next video lesson, you are going to learn or understand how to describe the waves. Thank you for watching.